Okay, here's just a little get ready activity to make sure that we're on track. You already have the anticipation guide for this chapter, but in order to get a better understanding of whether or not you feel ready for this unit, here are some questions that may help you. I will help you through some of them, and the rest I will ask you to do on your own. So, identifying Pythagorean triples. A Pythagorean triple is a set of three numbers that satisfy, and I want to use be careful in using math language here, three numbers that satisfy the Pythagorean theorem. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. And so, for example, 3, 4, and 5, so I'll say 3 squared plus 4 squared equal 5 squared. And of course, we know 3 squared is 9, 4 squared is 16, and 5 squared is 25. And of course, 9 plus 16 is 25, so 25 equal 25. So we know that 3, 4, and 5 would be a right triangle. I'll show you right here. 3, 4, and 5 would be a right triangle. 3, 4, 5. And that satisfies the Pythagorean theorem. So we can say one Pythagorean triple would be 3, 4, 5. Okay. Another one may be 5, 12, and 13. Okay, I'll give you one more, and then the rest I'd like you to either look up or see if you can figure out a way of coming up with them on your own. So 9, 40, and 41 is another. So you come up with three more on your own. All right, finding the perimeter of each figure. The perimeter of a square should be pretty simple because we have these hash marks that tell us that each side of the square is the same in length. So 4.6 meters, again, it's perimeter. So we're just adding 4.6 four times, or 4.6 four times. 4 times the 4 is 16, and 4 times 6 is 24, but in this case it's actually zero point 0.6. So I want to show you a quick way of doing this with mental math instead of doing it the long way. So we're going to split 4.6 up into 4.0 and to 0.6. We're going to multiply that by 4 and multiply that by 4. 4 times 6 is 24, but 0.6 times 4 is 2.4. And 4 times 4 is 16. So 16 plus 2.4 is 18.4, and it's meters. Okay? That's the easy way of doing that mental math. The perimeter of a triangle, we'll have to use a Pythagorean theorem here. You know that a squared plus b squared equal c squared, but we already have c. C is always the hypotenuse, or the longest side, or the side opposite the 90-degree angle. Okay? That is always c, no matter what. So now we have 3 could be a or b. This other side length here could also be a or b, doesn't matter, as long as the hypotenuse is considered to be c. So how do we find that? We have to rearrange our formula because we have c and we have, let's call this a, and we want to find b. So we'll say b squared is equal to c squared minus a squared. So we're basically taking this guy and bringing him over. So b squared equals c squared minus a squared. C squared is going to be, what you're going to do here is you're going to sub 4.2 in for c, so 4.2 squared, and we'll plug 3 in for a, so we'll have 3 squared, which is 9. And then to get from b squared to b, you have to square root, right? So the square root of b squared is b. And if I square root that side, you have to square root whatever you had on the other side in order to get your answer here. So I'm going to leave that to you as well. Just wanted to lead you in the right direction. Of course, the perimeter of the rectangle, I'll see if you do that on your own. That should be quite simple as well. The circumference of a circle, we have two formulas for the circumference. The first diagram prompts you to use the formula. It's giving you the entire diameter. So circumference is pi times the diameter. The second formula, circumference, is 2 times pi times r. And I want to point one thing out here. We have 2 times pi times the radius. And just so you understand, the 2 and the r, I put them in red because the diameter, I'll put that in red as well, the diameter is the same thing as saying 2 times the radius, right? 2 times the radius is the same thing as saying diameter. So these formulas are the same. We just decide which one to use based on what's given in the question. So if we're given the radius, then why not use an equation for circumference that uses r, or the radius. If we're given the diameter, then why not use an equation that uses the diameter? That's just common sense. Okay, and a little bit quicker when you're doing your work. All right, let's take a look. Do we have anything else here for you to work on? Yes, we do. So finding the area of each figure. How do I find the area of a rectangle? Area, let's pull that up again. So for the area here, we have area equal length times width. For the area of a circle, we have area equal, I might just move that over a little bit for you, area equal pi r squared. That's the formula for area of, don't like that. That's the formula for area of a circle. And the area of a trapezoid, we've gone over this in class, I've done it on the board for you before, but just to refresh your memory, let's see if we can recall this. So the formula for area of a trapezoid is A plus B times the height divided by 2. Okay, so the area of a trapezoid is equal to that. You might recall that this is really when a trapezoid is really when you have a parallelogram that's been cut in half, cut in half like that. You end up getting two trapezoids. Okay, all right, and get rid of that. The surface area of each object. To find the surface area of a cylinder, what you want to do is you want to be able to open that up and take a look at what the net would look like. And the net for a cylinder, you may recall, looks something like this. Circle and a circle here, right? So if you have two circles and a rectangle, you're going to find you're going to use the formula for area of a circle. Area, of course, is pi r squared, but we have two of them. So in this case, you could actually insert 2 pi r squareds, or just figure out what pi r squared is and then double it. And to find the length of this rectangle, the length is going to be equal to the circumference of the circle, and then the height of this circle is going to actually be the same as this 12 centimeters here. That's the height. Okay, so you're going to have to find the circumference to find the length, and then once you've got those three, you're going to find the area of the circle twice. So area of the circle times 2. And then you're going to also find, that's step 1. And step 2, you're going to find the area of that rectangle. But you're first going to have to find out the circumference of the circle, because the circumference of the circle is the same as the length of that. So just imagine that you actually cut this open up, here like this, right along that line. Made a slice right there and unfolded that. Basically, you'd have one long rectangle, and so the circumference of the circle and the height are right there. I'm hoping that makes sense to you as well. And this is the surface area. So this is a rectangular, I guess. Okay, so you have 2 times 2 times 3. That would get you the volume, right? 2 times 3. But if those are so what I want to look at first is our front surface area, this right here of this front face. So that would be 2 times 2. But then in the back there, I'll do it a different color. In the back there, that's also 2 times 2. So we have that twice, right? Then you have, let me erase this. Then we've got, use a different color here. Then we've got this face right here as equal to that face right there. So we've got 3 times 2 twice. And then you've got the top and the bottom of this structure. So the top, let's use pink. The top and the bottom, those are also the same. So then you have, top and bottom. The top is 2 by 3 as well. Right, so you had 3 there, that's 3. And so that's 3 by 2. Okay, so 3 by 2 twice again. Add those all up and get your answer and add the total. All right. Draw and label a net for the triangular prism. I am going to, I shared with you volume here. All right. Find the surface area. The volume of a prism is area of the base times height. Equal area of the base times height. The volume is area of the base times height. The volume is also known as length times width times height, but that does not work with this triangular prism. Okay, so the net might look something like this. We have one triangle, and you're going to label this. Then we have, sorry, rectangle. Then we have another rectangle. Okay, and I'm going to put one right there. And then we have triangle like that. Another one on the other side. Okay, so that when you fold that, it works out well. This might be able to be, might be a little bit bigger. Something like that. Okay, so when you fold that, that's the net. And then you're going to label this and find out the area of 1, 2, 3, and 4, and 5. Okay, and add them all together. And the volume you'd find by finding the area of the base times the height. Keep in mind that the base is actually the triangle. Okay, because the prism has the same base and the top. And that's what the base is. The base is a triangle and the top is a triangle. That's why we call it a prism. All right, you're on your own with this, and hopefully it brings back some of those strategies and concepts and skills you learned in grade 8. We'll see you in class.